Welcome to a pretty wild biological mystery about, well, our very own bodies. In this explainer, we're basically going to act as physiological detectives, and we're investigating a really fascinating quirk of the human nervous system. We're going to solve the puzzle of a sensation that literally requires someone else to exist, and figure out exactly why our brains deliberately hide certain feelings from us.
Okay, I want you to actually break the fourth wall with me here for just a second. Go ahead and try to tickle yourself right now. Seriously, take your fingers, try to tickle your inner forearm, maybe your ribs or your neck. Did it work? If you're like most people, you found that doing it to yourself completely fails to produce the shivers, the giggles, or that really intense ticklish reaction that an external touch would cause. I mean, you can feel the touch, sure, but it has absolutely zero tickle power. But why is that?
All right, so Section 1, A Tale of Two Tickles.
To solve this whole thing, we first really need to understand our victims. Because, as it turns out, not all tickles are created equal. Coined way back in 1897, science actually divides tickling into two totally distinct phenomena. First up, we have kismesis. Now, this is a light, superficial, kind of creepy-crawly sensation. Think of a feather or a little insect walking across your skin. Its evolutionary purpose is most likely to warn us of parasites. And crucially, you actually can partially self-induce kismesis. But then there is gargalesis. This is that heavy, rhythmic pressure at super-sensitive spots, like the armpits or the soles of the feet. It triggers this completely involuntary, reflexive laughter and writhing response. And gargalesis is entirely impossible to self-induce. So our mystery today centers strictly on gargalesis. Why is this specific laughter-inducing tickle totally impossible to do to yourself?
Which brings us to Section 2, the brain's prediction engine.
To find out who is stealing the sensation, we really have to introduce our prime suspect here, which is a highly complex predictive tracking system located right at the back of your brain, in the cerebellum. You can kind of think of your brain like a set of really high-tech noise-canceling headphones. You know how those headphones use tiny microphones to listen to outside noise, and then they instantly play the exact opposite sound wave into your ear just to cancel it out? Well, your brain does the exact same thing, but with touch. So, step 1. Your motor cortex sends a command to your hand to, say, move towards your ribs. Step 2. A carbon copy of that command gets sent straight to the cerebellum. Step 3. The cerebellum runs a lightning-fast simulation, a forward model, predicting exactly what that touch will feel like. And step 4. When your hand actually makes contact, the sensory feedback is actively, precisely muted.
That carbon copy of the motor command we just talked about actually has a specific scientific name. It's called an efference copy, or a corollary discharge. Before your fingers even touch your skin, this duplicate signal empowers your cerebellum to calculate the exact timing, the exact spatial location, and the physical intensity of your impending self-tickle. Your brain is essentially seeing the future of its own movements. And this is it. This is the biological mechanism that serves as the ultimate answer to our mystery, somatosensory attenuation. Because your brain so accurately predicted the sensory outcome using that efference copy, the central nervous system actively cancels or dampens down the sensory feedback. It essentially just deletes the tickle sensation before it can even fully register in your consciousness. Now, on the flip side, when someone else tickles you, well, there is no efference copy, there's no prediction, and therefore absolutely no cancellation. You just feel the full, overwhelming force of the gargalesis.
Let's move to Section 3, catching the brain in the act. Now that we have this working theory, we really need physical evidence to prove it actually exists inside our heads. And we have it. Functional MRI scans from a really groundbreaking study by neuroscientists Sarah Jane Blakemore, Daniel Wolpert, and Chris Frith reveal exactly what we've been discussing. When the touch was externally produced by someone else, the somatosensory cortex, which is the part of the brain that processes touch, it lit up vividly on the scans. But when the subjects produced the exact same tactile stimulus themselves, that region was significantly deactivated. The actual perceptual experience in the brain was physically lowered, all because the cerebellum successfully predicted the input. Basically, we caught the brain deleting the tickle in real time.
All right, Section 4, exceptions to the rule.
In science, the absolute best way to prove a rule is to find edge cases where the system just totally breaks down. Take this beautifully bizarre setup from an experiment by that exact same team. Subjects used their left hand to move a rod, which electronically triggered a robotic arm holding a piece of soft foam to move and tickle their right hand. By using a robot as this sort of middleman, the researchers could digitally manipulate the exact timing between the subject's motor action and the resulting sensory consequence. And the breakthrough happened when they added a temporal delay, when the robotic interface delayed the tickle by just 200 milliseconds, literally a fraction of a second. The subject's tickliness reading drastically increased. Even though they generated the movement themselves, that tiny delay broke the precise temporal prediction of the cerebellum's forward model. The efference copy no longer matched the actual sensory feedback coming in, so the brain just stopped attenuating it and the tickle sensation came rushing right back.
Now, there is also a really profound medical anomaly that backs this whole predictive theory up. Studies have shown that patients diagnosed with schizophrenia, or even non-clinical individuals who just have high schizotypal traits, can often successfully tickle themselves. Unlike the rest of us, their self-touch feels just as ticklish as an external touch.
In these individuals, that corollary discharge process we talked about, the sending of that efference copy, it just doesn't work in the usual way. Their brains do not generate an accurate sensory prediction of their own movements. And while this obviously allows them to feel the self-tickle, it also helps researchers deeply understand some of their more severe symptoms. Think about it. If your brain doesn't correctly tag a movement as self-generated by dampening the sensation, your own actions might suddenly feel like they are being controlled by an outsider or even supernatural force. This can lead to delusions of control, or what we call passivity experiences.
Which leads us to our final part, Section 5, the boundaries of self.
As we wrap up this mystery, we really have to look at the grand evolutionary motive here. Why on earth did human survival demand this incredibly complex cancellation system in the first place? Well, it all comes down to efficiency and survival. Somatosensory attenuation frees up your brain's processing power. Think about it for a second. You are constantly moving. Your arms rub against your sides when you walk. Your clothes brush up against your skin. Your tongue is constantly moving inside your mouth. If your brain didn't constantly mute the sensory feedback of your own predictable movements, your nervous system would be completely overwhelmed with useless noise. By filtering out the self, your brain ensures it has the bandwidth to instantly detect an unexpected, externally generated stimulus. Like a predator grabbing you from behind or a dangerous parasite crawling on your skin.
This actually points to a pretty staggering conclusion. The profound neuroanatomical distinction between self-touch and social touch provides the essential foundation for our sense of agency. What this really means is that the simple, maybe slightly disappointing fact that you can't tickle yourself is actually the fundamental mechanism that allows your brain to maintain a stable, coherent boundary between you and the rest of the physical world. It is literally how you know you are the author of your own actions. Which leaves us with this final, honestly mind-bending thought. The inability to tickle yourself isn't just a quirky party trick. It's the very architecture of your identity. If your brain wasn't actively muting your own movements every single second of the day, would you even know where you end and the world begins? It's a pretty profound reminder of the invisible, complex calculations happening in your head every single millisecond. Thanks for joining this explainer on the Great Tickle Mystery, and I'll see you next time.